Exercise 1.3, question 2. Prove that 3 plus 2 root 5 is irrational. Now this question is really an easier version of question number 1 in this exercise. But it is easy because we've already done question number 1. So if you haven't watched that video, watch that first and then come to this. You'll understand this all the more. So to prove that this is irrational, we will first suppose to the contrary. Contrary means in the opposite direction. In fact, if I want to prove that A is equal to red, I just assume, okay, let's just assume it is not red. So to the contrary, you will assume that this is rational. Okay. Now, if this is rational, then what do we know about rational numbers? We know that if it is a rational number, then we can write this in the form P by Q, where P and Q are integers and Q is not 0. But you will see from question number 1 that after writing it this way, we did one more step where we cancelled out any common factors that P and Q might have and wrote it again in the form A by B, where A and B had no common factor other than 1. In other words, we can say A and B are co-prime. Co-prime is used for two numbers that do not have any common factor other than 1. So I will straight write it using A by B instead of first saying P by Q and then cancelling out common factors. So you will say if it is rational, then 3 plus 2 root 5 can be written in the form A by B, where A and B are co-prime. Now, from this, I can find out the value of square root of 5. How? Look here. So I have A by B on the right hand side. From this, I can first subtract 3, which will be 2 root 5. And then I will divide this whole thing by 2. Now, if you simplify this, here's what you will get. This numerator will become b here, the denominator will be b, you will have a minus 3b, and then the whole thing is divided by 2. Now, when you simplify this further, this will become a minus 3b over 2b. So this is what your root 5 has become. Now look very carefully. A and b that we had were both integers. If a and b are integers, then a minus 3b is also an integer and 2b is also an integer. So here what you have is one integer divided by another. Yet again, the denominator is not 0. How am I so sure? I'm sure because this 3 plus 2 root 5 is what I had taken to be a by b. And so b had to be non-zero. And if b is non-zero, then 2b is also non-zero. So if this is written in this form, then what I can conclude is that this number here is rational, because it is written in the form integer divided by integer where the denominator is not 0. But square root of 5 is equal to this expression. So if this expression is rational, then square root of 5 will also have to be rational. But this is not possible, right? We have already proved in question number 1 that square root of 5 is irrational. So you will say, but this is a contradiction. Just see how I've written this. As I said, this is a contradiction since square root of 5 is irrational. Now, why did this contradiction arise? This contradiction has arisen because of our incorrect assumption in the beginning. The assumption was this that we made right in the beginning, supposed to the contrary that this is rational. So our incorrect assumption was that 3 plus 2 root 5 is rational. And now that we know the assumption was incorrect, what can we conclude? That 3 plus 2 root 5 is rational. Hence, proved.